Today, we tackle a common array manipulation challenge, creating a new array by simply duplicating an existing one. It seems straightforward, but how can we do it efficiently and elegantly? The problem asks us to take an integer array, let's call it nums. Our goal is to construct a new array, answer, that is twice the length of nums. The answer array should be formed by concatenating nums with itself. So if nums is elements 1, 2, 1, the result should be 1, 2, 1, followed by another 1, 2, 1. A straightforward, brute force approach involves creating a new array of double the original size. Then we can iterate through the original array twice. First, we copy all elements of nums into the first half of our new array. Subsequently, we iterate through nums again, copying its elements into the second half of the new array. This works, but it's essentially two separate loops doing similar work. This approach has a time complexity of big O of n because we iterate through the array twice, and a space complexity of big O of n for the new array. The key insight here is to leverage built-in language features for array manipulation. Many languages provide methods specifically designed for combining collections. In CSharp, for instance, the link extension methods offer a concise way to achieve this. The idea is to treat the array as an enumerable collection. We can then use a method like concat to append the array to itself. This method returns a new enumerable sequence that represents the combined elements. Finally, we convert this sequence back into an array using the toArray method. This single line of code encapsulates the entire concatenation process, making it highly readable and less prone to off-by-one errors that can occur with manual indexing. Let's trace this with our example. Nums is 1, 2, 1. First, we call concat on nums, passing nums itself as the argument. Conceptually, this creates a stream of elements 1, 2, 1, followed immediately by another 1, 2, 1. This stream isn't an array yet. It's a sequence waiting to be materialized. Next, the toArray method takes this entire sequence and allocates a new array of the exact size needed to hold all 6 elements. It then populates this new array with the elements from the concatenated stream, resulting in the final array, 1, 2, 1, 1, 2, 1. The final array for input 1, 2, 1 is 1, 2, 1, 1, 2, 1. This is correct because it's simply the original array appended to itself, fulfilling the problem's requirement. You'll spot this pattern whenever you need to duplicate or combine existing collections. Look for opportunities to use built-in concat or similar methods when the problem involves appending one collection to another, especially when the collections are of the same type and structure. This optimized approach achieves a time complexity of big O of n because it still needs to iterate through all elements once. The space complexity is big O of n for storing the new concatenated array. Mastering these concise, idiomatic solutions can significantly improve your code's readability and maintainability. Try the next problem, same pattern. Don't forget to like and subscribe for more DSA insights.